Welcome everyone to the zIIP stream. Today we've got Mary Solomon from SMT Data, who's going to be presenting on mainframe performance tuning. This session is 6AU, so please do remember that when you're filling in the feedback form towards the end. And also we'd be very grateful if you could donate to our nominated charity of the year. It will give you a chance to enter the prize raffle as well. In terms of Q&A, Mary will be answering questions towards the end of the presentation. So if you have got questions, please do leave it in the chat box and yeah, we'll get to them at the end. So with that in mind, over to you, Mary.
Yes, thank you. First of all, thanks to GSE UK for this wonderful opportunity to talk about mainframe performance tuning. Welcome everyone. My name is Mary Solomon. I'm in this mainframe industry past 8 to 9 years and mainly in mainframe performance and capacity management. I have started my career in IBM and I have worked for DXC and Danske Bank Denmark, and I'm currently in SMT Data Denmark providing mainframe performance and capacity support for multiple customers in Nordic region. This is my short intro about me. Please consider showing your interest by kindly donating to our charity for this year, GSE UK. Today, I'm going to talk about mainframe performance tuning. In my current job, I have that opportunity to make mainframe monthly health check report for multiple customers every month. So I thought I can share some of my practical experience with you all. Now, first of all, what is performance tuning? Performance tuning is the improvement of your system performance. And even the most systems will respond to increased load with some degree of decreasing the performance. A system ability to accept the higher load is called scalability, and modifying the system to handle the higher load is called performance tuning. Tuning is a key factor when coming to the performance tuning. The goal of the performance tuning is to make to best use of your current resource to meet your current objectives. For effective performance management, you need to go on to measure your resource requirements at the workload level and even the system level. Analyzing your workload, it helps you to understand your system behavior and to your hub workload interacting with each other. And the next one, and ensure your applications are using your mainframe CPU efficiently, even both maintain service level and to keep cost in your control. Mainframe application performance management, also known as the performance tuning, this can help you to identify and correct application coding error and inefficiencies in order to deliver the faster response and to reach the service level. More efficient code should also result in the same workload being handled using less processing power, helping to minimizing used-based software licensing charges and reduce the pressure to invest in additional processing capacity. First of all, if you want to do the performance tuning for your system, first you need to understand your system, what's really going on and which workload it's taking a high CPU. So to optimize the performance of your mainframe, first of all, you need to understand what's going on inside in your system. For that, you have to use efficient tool to measure your system performance. The second one, how to understand which workloads are placing the greatest burden on your system resource. For that, you have to measure your online and batch workload CPU pattern. The third one, what specific operational bottlenecks and processing inefficiencies need to be addressed. The fourth point is very important one, how to performance baseline compare before and after optimization of your effort. Not only the before and after optimization. See, now if you are outsourced to outsourcer, if they done any upgrade or any changes in your mainframe, it always good to measure your before and after your performance data. For example, if you upgraded your kits or a DB2 or a disk device, anything, or if you implemented any capping techniques, or if you implemented the resource group at the workload level, it always good to know before and after your performance data. The next one is WLM workload. First, it's important to understand the meaning of WLM importance and controls. As you may know, all work in the system is assigned to the service class, and each service class is comprised of one or more service class periods. At the period level, that work is assigned to a goal and importance level, and optionally a period duration of service. Each service class is associated to an importance level that specifies how important it is to your business. Here I have pasted one graph, and this is for the WLM system task average MIPS usage for the selected period. So here you can see before 8th April, it fluctuating between 25 to 30 MIPS, average MIPS. And after that, after 8th April, and you can see the WLM system task MIPS usage, moreover, the very stable. The reason behind for this one, before that, this customer have defined all the kicks region in one service class and a one goal, like prod kicks region, test or development kicks region, everything together in one bucket, one service class and one goal. And the later part, they have divided this service class into 3 different groups, one for prod and one for test, and they 3 different group and 3 different goal and 3 different importance, WLM importance. So what I can understand from this case, if you divide this workload, that will reduce the burden from WLM task. That's why you can see the pattern of the CPU usage more stable after this WLM change. So just think about that. Next one is workload balance. Even here you can see I have pasted one graph in the right hand side. Yes, this is the workload average MIPS usage in 24 hours and 1 day, 28th October. Here in the blue area is indicating the batch workload, and the green, yellow, that orange, everything is online, and the DB2 and the system task in the down black one. If you see, first of all, if you see the first, if you notice this graph, what it will pop up in your mind? Like, what is the reason why batch everything running during 0 to 7th hour? You have, there is some of white space even in the evening time. So it automatically comes the first question. You can move some batch into evening time. You can use that white space. So that's also first point, because there is no condition to run all the batch should run on 0 to 7th or in the morning time. You can move some batch into evening and use the white space. Second thing, try to identify the major contributor during this time and review your WLM definition and divide the workload based on your business SLA. And if you see this graph, it's very clear this client is paying money based on the batch peak, not online peak. And during the peak hour, you can see online, it utilizing more than 2000 MIPS. That's all. But batch is taking this system into more than 3000 MIPS. Here really we have to think about that, how we can optimize the batch and how to balance this workload from 0 to 7 to evening time, 18 to 23 hours. And second point, I can tell you in this system, all the batch running under the production batch service class. We all know that we have some other service class called test batch or a development batch. You can define some selected test batch into the test batch service class and give the less important to that workload. So your higher priority batch will run with a higher priority, and even next the test batch will run after that one. So WLM will manage that priority. Whatever I said, you moving some batch from here to there, or if you make resource group level capping to reduce your batch usage, or you divide some batch into test batch, whatever it will be, it's all the solution, but it's not a permanent solution when coming to the batch optimization. But if you want to really do the batch optimization for your batch, we have a wonderful tools from IBM like APA, IBM Application Performance Analyzer, and Strobe. From this tool, you can analyze your batch and try to understand which step and which program is the reason for the high CPU usage. And from that, you can optimize your batch. This is the permanent solution when coming to the batch optimization. For example, I have met many system programmer in the in mainframe industry. I discussed with them about their batch optimization because I heard from them is most of the batch all created 15 years before or 20 years before or 10 years before. This is all not recently created batch. Sometimes to think about to revisit your program logic to understand the pain point to improve your code efficiency. That's also plays the main role in batch optimization. Second thing, upgrade your compiler. Even this is also one of the point I always discuss with the customers. IBM has been cautious about the maintaining backward compatibility so that when a mainframe OS or a middleware or a hardware is upgraded, application program do not have to be recompiled, but you may well have some COBOL or PL1 programs that should be recompiled anyway. Using COBOL 6.3, it reduced an average CPU usage 58% over application compiled with COBOL version 4.2 on C15. IBM said that aggressive use of the latest compiler technology is the biggest single performance lever for many applications, and it can result in the CPU time reduction. So keep this also in mind. What is the version of compiler or using, and think about in upgrading the compiler version. Next one is a code efficiency. Yes. Poorly written, the COBOL or SAS or DB2 SQL code can significantly degrade your performance. For example, performing the sorting or a date selection in your program logic is exceptionally inefficient. So here also you can use the IBM tool called Application Performance Analyzer or STROBE from BMC to review your program logic that will help you or drive into code optimization or code efficiency. And I'm moving to now capping. Capping is one of my favorite topic in mainframe performance tuning. First of all, we should know about in our environment how many capping we have initiated and what is the purpose of the capping we have initiated, and try to understand what kind of control that providing into your infrastructure. The reason you could consider capping techniques in a two-way. One is technical motivation, another one is a financial motivation. When I discuss with the system programmer, they always talk about the technical motivation. They'll discuss with me like, my batch is consuming so much. Can you recommend something in the resource group capping? Or my test system is taking all my production capacity. Can you make a absolute capping at the test LPAR? This kind of a talk will discuss with the system programmer. That's all in a purely is a technical motivation. But when we discuss about our IT operation managers, they will talk about the financial motivation, because they will ask about the overall our LPAR, overall our system don't want to consume, for example, more than 3,000. They'll tell, is it possible to keep your capacity line to 3,000 MIPS? That's a financial motivation. Let it be. But technical motivation, it will protect and isolate LPAR against other LPAR and guarantee unused CPC processor capacity and protect your workload and set of service classes against with the other service classes. And coming to the financial motivation, it will limit your software cost and based on the guarantee capacity limit for one or more LPAR or 4 hours rolling average consumption. Next one is the capping types. Yes, we have a different capping types in mainframe techniques. One is LPAR initial hard capping and LPAR obsolete capping and defined capacity at soft cap, LPAR group capping with a soft cap and resource group capping. Next one, I'm going to talk about the defined capacity and the capping method called average adjustment weight for pricing management. Yes, I have pasted some table data also here, and I have selected 4 measure from SMF70. SMF70 LAC and SMF70 MSUs. LAC is nothing but a IBM 4 hours average hourly MSUs, and the SMF70 MSUs is the defined capacity MSU limit if enabled. If customer is enabled this defined capacity, you will get the number over here. The third one is SMF70 NSW, that is percentage of when LPAR was soft capped. Fourth one is average adjustment weight for pricing. This customer asked me very direct question to me, like, we have defined as a 47 is a defined capacity for this LPAR, but the 4 hours rolling average MSU usage is using more than the limit. 47 is a limit, but you can notice here 47, 50, 52, 54. It is using more than the limit. It is using the more than the defined capacity because this is the average adjustment waiting for pricing management. There is a 2 more variable here, 89, 100, 100. It reached that soft capped. And once it's reached the soft capped, automatically that average adjustment waiting for pricing model, it increasing the MSU usage, see 13, 15 and 15, 15. That's adjustment, it will happen automatically when it's reached the soft capped. The next topic is memory. Memory also one of my favorite topic in mainframe performance. Because when I started my career in IBM, I got a lot of training for the mainframe performance and capacity management. Then I started working in the client environment, but I always think about the overall system, CPU usage, or IO count or other stuffs. I never ever think about the central storage size for that environment, but it always important to get to know about your central storage allocated for your environment and available frame queue and paging rate. Central storage plays an important role in all the system activities like hypersorting, data space sorting, and memory object sorting. It always good to know the allocated central storage size and available frame queue. It plays the main role in your system activities. And coming to the paging, also important factor. So high paging rate, it always indicate the memory constraint. Example, DF sort bases its use of these very efficient sorting methods on the amount of central storage it can use without causing the excessive paging on the system. Next one, yes, I have pasted some two graph here. This is about the critical storage shortage. One of my customer very recently done an IPL due to critical storage shortage alert. Here you can see the 12 GB. This is for the available frame queue size. And you can see in July 1st, you can't find even a 1 GB available frame queue during that time period. And the second graph is a blue, light blue and a dark blue that indicating the paging rate. So 5K paging rate is recorded during that time. So what happened on the day? The DBM1 data manager task, it consumed a lot of memory, and it due to the high memory, high demand, created the memory constraint, and they got the high critical storage alert. In between that time, system went down and they can't do any action after that. They done the IPL after that one. So my point here is always keep eye on your alert in your console. This for the IT operator, and keep eye on the paging rate and your available frame queue. Next one, so storage shortage alert. We used to get the 3 type of alert in the console. First one, once your storage is reached at the 50%, it will send the information level alert. It will issue the IRA 405I, tell the percentage of the real storage is fixed. Second thing, once it's reached the 80%, it will send the storage level alert, storage shortage level alert. It will issue the IRA 400E and IRA 404I. It will send some details to your operator. And the third one, don't miss the first and the second level of alert, because the third one take it into the critical level. Third one is a storage shortage alert at 90%. It is the critical shortage level alert. IRA 401E will issue that one And in this case, continuous for 15 seconds issue the IRA 420 and 421. Show the largest consumer and allows operator to cancel them during the alert time. Next one is a memory report. We have a different tools right now in the market, but RMF, if I tell openly, RMF is one of my favorite tool in Mainframe to monitor the real time, even the post-processor report. So first thing, RMF monitor 3 storm report or RMF post-processor report for paging. It will provide you memory and memory subcomponent data for you. Otherwise, SMF type record 71, you will get a lot of details, paging information or memory, will get that data from SMF type 71. The next topic is KICS application performance. KICS application performance is a wide topic, but I don't want to talk very deep dive KICS application performance here, but I'm going to talk some basic thing about the KICS application performance. Before you tune a system, first understand why your KICS is not performing as expected. But if you want to understand your KICS application, I'm using the two sources. One is from interval 30 record. It will provide the KICS region level CPU usage information. But that is the first place it will indicate you if KICS is really taking a 2-3 hours continuously high CPU, that directly indicating some transaction is behind the reason for KICS region high CPU usage. If you really want to know what KICS transaction is running during the time in under the KICS region, you have to use SMF record 110. It will provide you the KICS transaction data, and you can identify from there the high number of event count, and you can get to know the QR and the Lite CPU of your transaction and transaction volume and the looping transaction, and you can monitor your KICS transaction CPU usage pattern and transaction volume and transaction response time. Sorry. In the right hand side, I have pasted two graphs here. The first one is the red one is CPU usage for the one single transaction, and the down one, green one, is the number of transactions triggered during that time in that transaction. But it started September 3rd, but you can see continuously it's taking more than 800 QR CPU up to September 7th, and the same amount of transaction also. If you see such kind of a picture report from the KICS, it directly somehow indicating you its transaction is looping, and it's a looping within the KICS because it spend a lot of time in QR. QR is nothing but how much time it spend on KICS, and L8 is nothing but how much time it spend on DB2. If you get such kind of a performance report, it directly indicating for you to check the transaction behavior or it's a looping transaction. Just review the program and find out before deploy such kind of a transaction into the production environment. Next one is a DB2 application performance. This is also very wide topic, but I don't want to talk deep dive DB2 application performance, but here I'm going to talk very basic things. Yes, first of all, even here, you want to know your DB2 address space CPU usage from your address space data, because there you will get it your distributed and the DBM1 and the DB2 task average CPU usage. That's what I have pasted. The first graph is the green one. It's showing the one distributed address space CPU MIPS usage from interval 30 record. If suddenly sometime distributed tasks started taking a very high CPU in many systems, I have noticed that one. But in that case, we can't control our eagerness to identify who is the user behind the distributed environment. It's taking a very high CPU. If you really want to know the end user, a DD of end user or authorization ID or IP address of the Windows server, you have to go to the SM of record 100 and 102, mostly in 101. Will provide you the DDF end user ID and authorization ID. Even you will get to know the system IP address. So that will help you to get some more clarity about this address space high CPU usage. Next one, I'm going to talk about the DB2 deadlock and timed out. One day, one of my mentor, and I guess he's a very senior person in DB2 Application Performance. He came to me and he asked me, can you provide DB2 IFC ID 196 and 172 report? If I frankly tell, during that time, I don't have a single idea about IFC ID 196, 172, but I have made a script and I have generated these two report and I sent it to him. Then I asked him, what could be the reason for that one? Why are you asking this 196, 172 IFC ID report? Then he explained to me how that timed out and deadlock is important in DB2 application performance. Logs are important for maintaining the concurrency in the DB2 environment. However, logs might cause several types of the contention situation that degrade your DB2 performance, including suspension, timed out, and deadlock. If you process IFC ID 196 will provide the timed out report, and if you read IFC ID 172, that will provide you the deadlock report. Here I have pasted one table data that's from 172 deadlock report. When deadlock, in deadlock, you have a two type of user. One is a winner, one is a loser. And here I have highlighted some of them in yellow color, that is CPU seconds. First, we can take the first instant here. 583 CPU second, and it ended with a deadlock. The holder, in this record, you will get the holder plan name and holder transaction name and the holder state. The holder is holding that resource in an exclusive mode, and the waiter is waiting to use that program. And the end, it's end with the deadlock, this transaction. So, but it spent 583 CPU seconds. And you can see that connection type, connecting system type code is a kicks attachment. You will get sometime TSO batch also in between that, but in this client I have noticed, but here I have pasted only 5 to 6 instant from the deadlock report, but I have noticed more than 100 deadlock entries in this prod environment. But this is not really a good when coming to the DB2 application performance, but this kind of deadlock and the log contention that will degrade your DB2 performance. So just think about that. Next one, offloading processing to the zIIP. Here in right hand side, I have a two graph. One here is showing about the blue one is for average zIIP MIP usage. The below one is zIIP eligible MIPS for a 1 LBAR. This is it during the peak period. It's consuming 1000 zIIP MIPS usage, but it's showing a 300 zIIP MIPS ineligible. It's good to see all the time when I do mainframe health check report for the customer, zip eligible also plays the main role on that one. I always check the zip eligible for them, because especially when they upgrade DB2, or if they now in Z15 we have a lot of product called zOS Connect E or Docker container, and many stuffs are zip eligible. So it's always check the zip eligible for your system, but in this case 300 automatically we can move into zip. That will reduce your general processor cycle. How you will reduce your, how you will move your general processor cycle into zip? First of all, you have to revisit the zip definition and configuration, which include the weight and the number of processor. So in this LPAR, if you add some more weight, that will help you to offload 300 cycle to zip, or otherwise, if you add one more processor into zip configuration, that will also help you to get additional 300 MIPS. When workload is dispatched on a zip processor, the processing cycles used to do not contribute to the MSUs count, and therefore do not impact your software usage charges. This makes adding new applications to the IBM C extremely cost effective, especially compared to competing platforms such as distributed system or a public cloud. Next one, what workload should run on the zip in a Z15? First of all, as you all know that DB2 distributed work, DB2 distributed relational database workload, most DRDA workload can lower their general computing power by offloading at least 60% of their computing to zip. The second thing is a hybrid cloud, gateway to hybrid cloud. New applications can access the cloud native services through zOS Connect RESTful API using zip. Modernizing your existing zOS application for a hybrid cloud environment can be started quickly using IBM Z processor. Next one is for zOS container extension, zOS Connect E. zOS container extension address space or zip eligible, and most zOS container extension processing, including Docker container, is deployed within the zOS container can be dispatched on available zip processor on Z14 and IBM Z15 system. 90% of the zOS container consumption was measured to be a zip eligible. The fourth one is IBM zOS Connect E. Nowadays, most of our customers started using this IBM zOS Connect E. Then I have noticed that using lot of zip. zOS Connect E is a Java-based product, so it's over 99% of the product is eligible for zip. Fifth one is a data virtualization manager for zOS. IBM Data Virtualization Manager enables user and application to read and write access to the IBM data in a place without having to move or replicate or transform the data. Data Virtualization Manager for zOS directly access zOS data set of bulk data access that brings significant MLC saving, resulting from up to 99% of zip eligible data. Java for new and existing application. As we all know, Java is eligible for zip, and modernizing existing applications with Java code or writing a new application in Java allows customers to run their workload on IBM zip. Seventh one is IPsec, security network encryption. That will be offload to zIIP. zIIP can be used to process the security IPsec network encryption and decryption. By running some of the IPsec network encryption and instruction on zIIP, organization can reduce their general processor CPU usage and lower their software cost. Next one is the XML processor. As we all know, this is a simple and flexible text format to be used in the data interchange on the web and in the electronic communication. So all the XML processing is eligible for zIIP. Machine learning. IBM Watson Machine Learning for zOS uses the zIIP engines to bring intelligence to transactional application. Third one is capacity for system recovery boost. zIIP can provide the additional processing power to the system recovery boost. In this C15 feature, reduce the impact of the downtime, even both planned and unplanned outage. 11th one, zOS management facility. zIIP can be also, you can offload zOS management facility framework work to zIIP eligible. Up to 95% of zIIP eligibility can be attributed to zOS management facility Java workloads. 13th one is zIIP eligible. zIIP can be lower your IT cost. That's really true, because zIIP can also help lower the cost of the IT of distributed server environment. Java x86 workload can be re-platformed to IBM C to utilize the zIIP. And you can see the sample picture from from some IBM paper to see that x86 workload re-platform to IBM C. What it will happen? The 3 years of total cost of ownership for IBM Z T02 zIIP versus the 886 server is 77% lower the TCO over the 3 years. And the 11th one is other use cases for zIIP. Not only can general processor cycles are offloaded to zIIP for selected workload, zIIP technology can be used to reduce the cost of IT operations and data processing. Okay, right now I'm in the conclusion state. I'm done with all the main slides. The conclusion of my presentation. Performance tuning always plays a major role in terms of both cost and performance. It's always a high priority and worth doing it. Thank you so much to everybody showing that interest. And if anyone who likes more information or has questions, please feel free to contact me in an email or just communicate with me in LinkedIn. Just send out the message. That's all.
Thanks very much, Mary. That was really helpful. Yeah, thanks for that. Just looking at the questions, we've got one in the chat at the moment from Ravi Kumar, who's asking, does subsystems like KICS DB2 use latest hardware instructions? So I think that might be referring to one of your previous slides.
I didn't get, what is that?
Okay, yep. It said, does subsystems like KICS DB2 use latest hardware instructions?
The subsystem like KICS and DB2 use latest hardware instruction. Yes, definitely, yeah.
Okay, yep. And that's the only questions that we've got in the chat at the moment. But as you say, you've obviously got your email there as well. So if anyone does want to ask you questions separately, then they can do that. I'll just give it a few more seconds if anyone does want to type in the chat box for questions. Okay, it looks like we haven't got anything coming through at the moment. So yeah, just as a reminder to everyone, if you could please leave the session feedback for 6AU. I've left a link in the chat box and also a link to on how you can donate to the nominated charity as well. Thank you once again, Mary, for your time and for the presentation. We really appreciate it. For those that want to join the next ZPNC session, we'll be back in here at 2 p.m. to hear from John Baker from IntelliMagic. So thanks very much all, and take care.